another question. Just take a moment here to make sure that everything's working, that the audio's working. I think it is. Yeah, I got the chat over here. Okay, so I got the chat over here. Yeah, looks good. Alright, so we'll close the previous question, start the next one. So that was the previous one. Here is the longest arithmetic subsequence. Let's give that a shot. Okay, so given array nums of integers, return the length of the longest arithmetic subsequence in nums. Note that a subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. A sequence is arithmetic if sequence 5 plus 1 minus sequence of I are all the same value. 4, 0 less than or equal to I less than sequence.length minus 1. So nums 3, 6, 9, 12, 4, the whole array is an arithmetic sequence with steps of length 3. 9, 4, 7, 2, 10, 3, the longest arithmetic subsequence is 4, 7, 10. Nums 20, 1, 15, 3, 10, 5, 8, the longest arithmetic subsequence is 20, 15, 10, 5. Okay, I don't know an answer to this immediately. It's a challenging one. So there's 1,000 numbers, and the numbers are between 0 and 500 inclusive. I've seen questions like this before. It's a challenging one, to say the least. This might be... maybe the way to do this is... so, first things first, I think you can do it in quadratic time, possibly. With quadratic in the number of numbers, which there's 1,000, so that's manageable. And I think the way to go would be basically to each number, you're going to update all of the previous possible arithmetic sequences that you have. Like how many values are in a particular arithmetic sequence. So, starting from 3, it's not, well, yeah, they could start at any point. So, there's no sequences to consider with just one number. Then the next number, you would subtract this number from all the previous other values and take the, subtract it, actually. So you do, I don't know, subtract the other values behind this one. So 6 minus 3 would be 3. So the arithmetic sequence for 3 gets incremented, right? Is that correct? Well, there could be more than one arithmetic sequence of 3. This is the arithmetic sequence of 3 that begins at 3. Yeah. There could be another arithmetic sequence that's like 12 and 15, but if 9 wasn't here, then you could have 3 and 6 and 12 and 15 as 2 different arithmetic sequences with a length of 3. It's not obvious how to solve this. Alternatively, you could say, I wonder if you could use some kind of a graph algorithm here, actually, I think about it. Now that I'm thinking about it. doesn't seem right. That doesn't seem right. I don't know. Trying to think of a way I could do this. I've seen this question more than once too. It's a challenging question. I think every time I see this one, it stumps me because it's just hard to think about. Often you want to come up with something that's faster than quadratic time. That's, I think, the problem. That's why it typically is hard. But I really don't think you can do it faster than quadratic, realistically. At least not, you can't think of something like that quickly anyway. Excuse me. Well, one of the problems is that if you go left to right, then, like the arithmetic sequence 3, 6, 9, 12, and 6, 9, 12, this one is like subsumed. So you really want to go like right to left, I guess. Excuse me. Yeah, I'm not really sure, actually. I kind of want to use a map of maps and go right to left and say, okay, I add 12 to the map, and that has, excuse me, a size of 1. Every possible arithmetic sequence has a size of 1. Well, let's just say it exists in the map, right? And then you look at 9, and you say, okay, for all of the values that exist in the map, I can take the difference between 9 and that value. So in this case, it's just one value, and it's a difference of 3. And then I can say, okay, there exists a sequence of at least size 2, starting at 9. So put 9 in the map, and then also have a map of a map of other values, the other values that get placed in there. It's going to be the size. The key in that second map is going to be the size of the subsequence. And it's also going to be, the value is going to be the size of the subsequence, and the key is going to be the difference. So there will be a 9, 3 with 2. And so 12 is in the map, 9 is in the map, and 9 has another map, which there's a pair of 3 and 2, yeah. And 6 I could go through again through the keys in the map and say look at 9 and 12 and say okay, 12 exists. The difference is 6. 12 doesn't have anything keyed off with 6. So I can just say 6, 6, and 2, right? And then I do the same thing with 9, and I see it is keyed off at 3. So now I would do 6, 3, and 3, right? And that would use a quadratic amount of memory if I did it that way, by the way. That works, but it's maybe not the best. Interesting. Also, I can reduce the memory slightly because and not have to use unordered maps because these numbers are bounded. Excuse me. Okay. Okay. Alright, I'll do it that way. Okay. We're gonna say no, it's gonna be right minus current. Oh, but these could be negative differences. I didn't think about that. Shoot. Oh no. I mean, I could still account for that. It would be probably a little bit faster than using the whatever. We'll just use the unordered maps. It's fine. It's like, oh no. No. Okay, I think this is still correct. Sure. It's just an empty map. Okay, it's different. So if so, it's guaranteed to be in the map. This right value. Question is. Oh, that's confusing. I forgot what it was even. Oh my goodness. Oh boy. Okay. It's like, this is confusing. It's something like this. Something like this. Gee. Okay. There's probably also a more optimal way to write this, but I'm just gonna go with this for now. Take a deep breath. Take a deep breath. Okay, I think it's correct what I've got here. Yeah, I don't know. Let's just try these basic test cases. I think I took a while on this one. Yeah, 17 minutes is a little bit longer than the other ones. I got kind of stumped, quite frankly. Sort of stumped. Now something more interesting would be, like I was saying before, like 3, 6, 12, 15, and something else like 1, 2, 3, 4, 10, 11, 12, 13, and then 2, 3, 4, 5, something like this, I don't know. I don't know if this is correct, I'm gonna go for it. Could be wrong. There's a good chance of something wrong. Oh, I got it. Sweet. Nice. Alright, not bad. It's a bit slow. It's maybe a little slow. Oh my goodness. That's like very slow. Let's look at the solutions. That's extremely slow. Holy smokes. My goodness. Okay. Yeah, let's look at some solutions here. Excuse me. Most votes. DP, okay. Beginner friendly, alright. Undefined, undefined, undefined. Yeah, quadratic with both. Just gonna hash map. Oh, it's like the same thing I did. Yeah. That's almost exactly what I did. Yeah, I was gonna say, I think the two, it gets confusing, but you can optimize it a little bit. I think. Very similar to what I did. Almost the same thing. Now you can use a vector. This is faster. This is what I was thinking before. I was like, hey, you could do this a slightly different way. I'll come back to the vector approach. Okay. That's fine. I basically did the same thing, it's just slower. This is pretty involved, huh? Wait, why is this faster than everything else? Oh no, never mind. Why would this That's exactly what I did. This is what I did. Oh no. Oh, I used a vector. Yeah, there are two ways you could do this. You can use, okay, you can use one vector. Okay, hold on, let's go back. I should have thought of that. Oh no, whoa. Okay, that's a little bit faster. Okay. Okay. Don't need to do that anymore. Alright. That's always going to be at least 2. Now, my question is, I think I could just do... the maximum of the current difference and the right difference plus 1. Okay. Something like this. Okay. No. Some questions here. Gulp. Wait. Oh, that's clever. You can use the index. This might not be correct, actually. Oh, I think he did this a little bit differently than I did. Yeah, he went front to back. I went back to front. Oh. Okay, hold on, let's try again. Let's not use a map. Let's call it DP as well. Oh, I see. Okay. Let's try again. So this is I plus 1. Okay. So get this difference. Now what I want to do is say, so at each value of I, there's a map for a given difference, how many sequences I have. So I would say dp of j, I don't know. How does this work? Let me think. Hold on. I think about this. The values, I'm going left to right in both directions this time. Okay. Looking at all the differences. So at this particular point, whatever difference values I have set at I, right? I can update j with that. So it's dp of j of that difference is going to be related to dp of I of that difference. And it would be plus 1. Now, it's also going to be the maximum of these two. Because if you don't improve this value, there's no sense in updating it. Okay. Also, best is always going to be at least 2. Update best. I always add 1 because I skip 1. Yeah, okay. I didn't go through all the test cases. I'm just gonna try to submit this one, see if I get it. Might not be correct, I don't know. Oh, looks like it's right. Okay, this one's still very slow. Still really slow. Gee. Okay. 100%, he says. Oh my goodness. I guess the ternary is faster than, I guess the ternary is faster than the function call. So they remove this. I guess you don't need that. And then, this variable too. So instead of a I'm a little confused. What did he do? Count diff on J. I don't know. So, excuse me. If this exists, then you're gonna add 1 to it. Otherwise, you return 1. Oh, excuse me. My I's and J's are mixed up here. Did I and J? I did J and I. Oh, that's interesting. Wait, what the heck? What is going on? Oh, I see. He did up to J less than I. Oh, okay, it's a little different. I was gonna say, like, I think my code is quite a bit different than his. Something is not quite right. So what did he do? He did diff. And so now it's db of I diff. It's gonna be db of j to count. db of j diff plus 1. Or 2, which really could just be 1. And then best of db of I diff. Okay. Is this correct? This is what I did. I did something, again, I did it differently the second time. Oh, wrong. Holy smokes. Okay, wow. How about that? Okay. Gotta breathe here. It's wrong. Is that what he did? I is less than n, j is less than I. Nums 5 minus nums of j. dpi diff. dbj dot count diff. It's gonna be, oh, dbj plus, okay. It's gonna say, pretty sure I can basically copy paste to the answer. trying to get the same idea that he had. See, I think it's correct. It's not that much faster. It's faster, but not by much. G. He said it beats 100%. Is he lying? Is he lying? Okay. So, G. So you went left to right. No, I think you can do, I think you can do this. 1. Best plus 1. And 1 here. And I think that works too. let's try it. Okay, there we go. That's better. That's much better. And why you want to do it that way is because I think you can just get rid of this altogether now. Yeah, I think this is still correct. Could be wrong. Okay, it's slower now though. Why is it so slow? What? Why is it slower now? What? Oh my goodness. You gotta be kidding me. What is this? It's slower now. What? What? No, really? Oh my goodness. You're kidding. What is this? I have to still like kind of figure out what he did exactly. But why is that faster with an if statement? Sometimes if statements are better, it seems. It's pretty wild. I wasn't expecting that at all. That's kind of unusual. But yeah. Sometimes if statements are actually faster. Yeah, it's like half a second faster using the if statements. Okay. Well. Take a deep breath. Okay. Alright. That's pretty amazing. So yeah, the ternary is good. Yeah, I guess it just saves you the extra lookup at some points. I think that's it, really. Gee. What? What? I can't believe it. I can't believe it. It's not, it's like slightly faster. Presumably just one less lookup. Gee. Oh, there we go. Got some speed. Alright, let's just let's talk about like what this actually did. So what this is doing is you can do another save on lookups too if you do dp of I and diff. I don't know. Maybe this will make it a little bit faster too. Or slower, I don't know. Faster, even still, a little bit faster again. Okay, some improvements. Yeah, that's a pretty good improvement over 1900. Alright, I want to look for, what I'm looking for now is why is this correct? So, for each value I, we're going to look at everything less than or equal to less than I. And we're going to say, okay, take the difference for each of those values previous, to the left. And we're going to look at each of those values, the dv values, and find the difference up to that point. And then we're going to say, okay, if we've seen something there, then we're going to increment it by 1. Otherwise, we're going to take a value of 1, and we're going to set I, dp of I, with that difference to whatever that value is. So, okay, this is pretty straightforward. We're basically saying, look at all of the previous values, and each of those have a difference with the value we're looking at the moment. And if any of those have subsequences, arithmetic sequences with that difference, then we just add this value to that subsequence, the longest one. Yeah. That's basically it. And then we set at this point at the value of I with that for that particular difference what the longest CU sequence size is. And then we take our best of all of those. And here are just a few things I added in there to try to speed things up a little bit more. Okay, that's a pretty clever solution that they came up with. It's not that complicated. It's relatively straightforward. I thought of something similar to that. It's kind of what I was going for, something similar, but not quite the same. This is just a little bit better than what I had. I don't think this is this just saves a few more lookups as well. Although I don't think it actually didn't make it much better, which is weird. Oh yeah, okay, it's fine. Yeah, it's reasonable. So this is one less lookup in this iteration, or a few less lookups. And then this is done every time. These could also be iterators. No, not really. No, it's not easier with iterators. This part is, this lookup is saved once with using an iterator. Yeah, that's pretty good. That's reasonable. There might be a better way to do this still, but this is like a reasonable way. Alright. Submitted this like many times, so now let me stop here. Yeah, I keep checking the chat, I think is what I'm checking. So yeah, let me stop here. Thank you for watching. If you liked the video, give it a like and subscribe. And yeah, have a good rest of your night. I don't know if I'm gonna keep streaming here. This might be it for me. Maybe I might end the stream and start on another. Might end the stream and start another problem, or I'll just stop here. So yeah, thank you. Take care.